Hello everyone. In this video, we will learn basics of set theory and notation and some terminology about the sets. Let me start with the definition of set itself. A collection of objects is called a set. So you put any number of things, number, people, names, letters together, that will form a set. For example, one can come say that, okay, I am interested in all integer numbers less than 5 and maybe positive integer numbers. Let me just write here positive integer numbers less than 5. Well, this describes all the elements of that set, and I can actually list all the elements. So what can I do when you're trying to list elements of a set? You just put two curly brackets and then list all the elements in any order you like. The important thing is that all the elements are there, all the members are there. So here in this case it will be 1, 2, 3, 4. That is a set. So that's why we start such definition as the set of all positive. Or this could be a little bit different nature as set of all students enrolled in math 1228 this term. Well, you want to have list of all students with that property? Yes, you can. Well, go find the list somewhere in the Office of Register, which include all the elements and exactly tells you who are registered in this course. Okay, so those are just examples, but there are some terminologies and notation. Let us go over that one by one. So first thing, as you see, a set is defined by knowing their elements, their members. Yes, so we have a notation for this. So membership. With the notation is this guy here. It's kind of is epsilon or whatever you like to call. And how do we use this? This is like X is in A. What does this mean? This means that X is an element of A. Or simply we sometimes say, or X is in A. Okay. So that's the first thing. The second thing that we have a notation for, it's called subset. And the notation is this, and then there's an equality there. Okay, so how do we use this notation? We say a set is subset of another one. So that's how we read it. So A is a subset of B if all the members of A are in B. So all the members or the elements of A are in B. If you want to write it mathematically, you can write it like this. If X is in A, then you can conclude that X will be in B. Right? You don't need to know or be able to write those kind of statements, but that's what it will mean, this sentence. And that sentence, one is in wording, one is in the mathematical notations. Okay, so the third thing is, well, equality. Well, we use this notation, and well, two sets are equal if basically, so A and B are equal, B are equal if they have exactly the same elements or members. Or in other words, anything which is in A is in B, so that means that A is subset of a B, and B is also subset of A. Note that when A is subset of B, B can have elements or members which are not in A. So subset means that, okay, this could have more members, more elements. But when you have equality, it means that no, both of them have exactly the same number of elements. There's one last thing. There is this interesting set, which has no element. If I want to list all the entries, I don't have anything to list. This guy is a famous guy. It has a name. That is what we will use for that. And it's called, well, the name is there, the empty set. And the notation is like this. Okay, so do you want definition for that? The set, there's exactly one of those as well. The set with no elements. Well, there is this. So these are the main things that we have. There's one more thing that we will come back to that very soon. But let me just add this remark here that, well, all these notations that you saw, we can negate them by putting a line, a cross line on them. So to negate the above notations, other than the last one, we use the notation with a slash on it. So something is a member is that, something is not a member, it would be like that. A is equal to B, A is not equal to B. So X is in A, X is not in A is, or A is subset of B, you negated A is not a subset of. So that's just something that you will see in some works. Okay, let's do some examples now, knowing those ones. We have three sets, A, B, and C. The question asks to determine which one is true, which one is false. First, is B equal to A? So let's see. B has elements 1 and 2, and A has elements 1, 2, 3. Note that when you're working with sets, the order doesn't matter. The only thing matters is membership. Here you see that 3 is in A, but 3 is not an element of B. What does that mean? That means that, well, A and B cannot be equal. So you can see that this guy is a false statement. How about the second one? We are trying to see if B is a subset of, oh, by the way, this notation, my typesetting didn't work nicely, so that's the notation we will use. So B is a subset of A. Is that true or not? So we check one by one. B has 2 entries. So B has 2 members. 1 and 2. We have to check if 1 is in A or not. 1 is an element of A, and, well, it is already there, and 2 is also an element of A. So what we showed that is that every element, every member of B is a member of A. So that means that yes. So let me just try. Yes, B is a member of A. And that is why this guy is true. What was true? Okay. So B is a subset of A, but B is not equal to A. That's what we had from the first one. So the third property, the third statement says that is C equal to empty? Well, C is a set which has one entry. So note that C has one element or member. And that element or member is the empty set itself. Okay? So C is a set with one element. So that means that C is not the empty set, or is not equal to empty set. And, well, that means that the statement 3 is false. How about a 4? Is empty set subset of C? See, when you say A is subset of B, it means that B has all the elements of A, and it has something, it may have something more as well, yes? But it contains all the elements of A. Here, empty set has nothing. So C has, any set has more than nothing, yes? So the statement that is written here is actually true always. Empty set is always a subset, is always subset of any given set. In particular, empty set is a subset of A, empty set is a subset of B, empty set is a subset of C as well. Okay? Let's finish the video with one more example. Find all subsets of B. Well, when you're listing all the subsets, we already saw up there that empty set is the first thing. Empty set is subset of everything. So, or just this is subset. Then you have the subset with one entry, with one element. And then you have the entry, the subsets with two. In this case, there's only one. And let me finish this with a remark that every set is a subset of itself. And the second one is that the empty set is a subset of any given set. Later in the course, we will study how we can find the number of subsets of a given set.